Dr.G.Raja Singh Thangadurai is an aerospace engineer. He graduated from Madras Institute of Technology, Chennai in 1988. He did his post-graduation from the IIT Science Bangalore in 1991 and doctorate from IIT Madras, Chennai in 2003. He has made his significant contributions towards the development of liquid propellant rocket engines for indigenous surface-to-surface missile Prithvi. His applied research areas include development of propulsion systems and composite structures for supersonic cruise missiles. He is a member of Process Section Committee MTD7 of Bureau of Indian Standards BIS, which is responsible for the standards pertaining to light metals and their alloys sections of Metallurgical Engineering Division. He was commended for training of AOC and EME personnel of Indian. He served Army as an NIT Trichy, as an Prithvi Missile System, AICTE INAE Distinguished Visiting Professor. He was awarded the Scientist of the Year Award 2009 by DRDO. This requires a big round of applause, please. Hyderabad for his outstanding contributions towards indigenization of subsystems of Bramhom's weapon system. Now he will have a chat with us. Let's welcome him with a big round of applause.
So in the limited time, probably I'll spend some 15 to 20 minutes. So though slides are more, probably we'll rush through that. That's not more important. Once again, I thank Naresh Indian and ACE Academy for giving this opportunity to interact with a lot of youngsters. Basically, when I joined DRDL, Dr. Kalam was the director. So that time we used to have, what you can say, it is like a ceremony or it is a norm that newly appointed officers or scientists or whoever is there, they have to meet the director around 5 o'clock. That is till that time he'll be busy and all. So I was told 5 o'clock you meet the director. So because we have not heard much about Kalam also that time, even photos, everything and all also was not very familiar, 1991. So when I entered the room, I was looking for a big chair. Generally when we see, suppose big auditorium or any meeting is there, chairman's chair will be little bit higher or little bit bigger. So I was looking for a chair where director will be sitting. But they were arranged in a very clumsy manner. Director also doesn't have any chair. It was like a normal chair and he was sitting, then he was saying, hello, come. Then when that time itself, he was asking, how do you reduce the CD of Akash missile? That means many times he is thinking, he were not even interacted. The main problems, he keep on thinking about it. Compared to these other missiles, Akash missile will have 4 intakes. So the drag is proportional to the frontal area. So it was creating a problem. It is having a solid fuel ramjet. So he was thinking, that is the kind of a person. And when you see Dr. Kalam, I hail from a village, maybe 80 to 90 kilometers from Dr. Kalam. He is from Rameshwaram. I am next district, we are staying there. And he is also from MIT Madras, that is the college, same college where I studied. So he is our super senior also. So in that way, he was a lot to us. And the project what I am working, Project BrahMos, which made the best supersonic cruise missile in the country, the seed was sown by Dr. Kalam when he visited Moscow. That is that time when India is making liquid rocket engines, when they are making solid rocket engine, ramjet engine is the thing you have to do. That was his dream. So that will be fulfilled. So that is a project what we are working. So I'll just, one small presentation I have, and probably at the end or sometime you can have questions and you can ask. Okay, now around 12:03, 12:15, 12:20, I'll try to finish it. Okay. So basically, as Dr. Raja was saying that we had a very humble beginning. India was shown as the maximum importer of weapons. Especially if you missiles also, entire thing were coming from, that time we had a good relation with erstwhile USSR, that is Russia. And we used to have all weaponry from there. And that was a stage, forget about making the missile or testing the missile or integrating. we don't know how to buy a missile, how to write the specification, what means, what is the item we have to buy, what it should have. From that stage, thanks to Dr. Kalam, now we are having a lot of joint collaborations and we have reached. Still long way to go, but with all you people, definitely we'll reach. I can go to the next slide. Paucity of time, I'll add maybe, first of all, any of Mr. Naresh Indian has arranged some 4-5 colleges have come to our facility. Probably whoever have not visited, I give you an open invitation. You can tie up with him. You can come to Bramhom, which is having the world-class missile integration test facility, which was conceived by Dr. Kalam. So you are free to come and we'll give an opportunity to see all those things. Means the missile integration, how it is assembled, tested, how complicated it is. All you will be able to appreciate and how multidisciplinary it is. Each person has a work in that missile. So basically if you see the warfare, earlier it started with a conventional thing, how it is evolving. That's what we have given, like whatever ancient medieval period, now how network centric it is going. So it is evolving and new technologies also come with time. So I'll not go into the details actually. Any object thrown with the intention of creating damage to an enemy is a missile. Next we'll not, these are all available. If required, a presentation also we'll share with you. And usually missile development is a long cycle actually. You get the requirement from the users. Our users are Army, Navy and Air Force. So they'll see, this is the weapon I want, this is as to the specifications of it. Then based on that you will see whether it is feasible with the current technologies or you have to develop a technology. Then you have your preliminary designs, prototype, then critical design, test it, prove it. So it's a very long cycle. So generally if you conceive something, they come, it will take earlier days and all 2 years, 5 years, even more. Now they are all concurrently done and we are able to compress the time frame. So usually, because this one slide I can spend a couple of minutes. So any missile, the intent or purpose is to send some destructive portion, whatever is there, from your place to the enemy's place. Some warhead, something which can create damage to the enemy's territory. So you have to, from your launch point, impact point, you have to send it. So if you want to send it, you have some power or engine to move it. Okay. So that is how you need a propulsion system or an engine towards that. And you want this missile or object to travel in a specified path. Suppose if you are predictable, you have to avoid that. If there is a mountain coming in the way, you have to avoid it. If you want to evade something, you have to do. So you plan a path that we call as a trajectory. So when the missile is going in that, whether it is going or not, that you have to check. Any mid-course correction I have to do, check it whether it is going in the intended path or not. So that is called the control and guidance. So anything, all the missiles will fall in this category only. So you have what is the warhead you are carrying? Is it against an aircraft? Is it against a city? Is it against a nuclear plant? Is it against a runway? Or is it against a satellite? Or is it against something? And from where you are launching and how you are launching and in what way it has to travel. This is how is the crux of the problem, and all the things will fall in this major, this is the gambit of the missile design. Next. So this I will not go into detail. You can see that there are a lot of varieties. And one more thing is basically supersonic, whatever we say is any missile going, flying more than the sonic speed, Mach 2, Mach 3 like that. And there are another variety called ballistic missile and cruise missile. See, many of you might have traveled in an aircraft. So the aircraft just starts from rest, accelerates, picks up speed and climbs. Once it climbs, once it reaches some altitude, what we call as a cruise altitude, he goes straight. So that is what we say cruise phase. That means the attitude, the velocity, everything they keep constant. So any missile having that kind of trajectory is called a cruise missile. Other thing, ballistic, like you will have some propulsion. You will, as long as you are able to boost it, it will boost. Then later like a projectile and all, usually it follows a parabolic path. That is, they are all ballistic missiles where you want to have for a long range. Whereas this cruise missile, they are all powered throughout the flight. Next. Next we'll go. There is not much time. So some videos also I'll show, and if any questions. Go ahead. Next. No, depending on various classifications only. Next. And one more thing is sometimes we call as a conventional missile and a strategic missile. Usually strategic missiles have the nuclear warhead. That is the difference. Next. So many warheads are there, as I told you. Next. Even sometimes there are something like called a graphite bomb also, they say. That is, when you do that, it will short circuit the power station and the entire city, there will not be power. So different kinds of there are weapons are there. Yeah, next. And usually you optimize your missile for various parameters, whether it is with the miss distance or the lethality or so many things. Okay, next. And this is applicable to anything. See, suppose any product if you want to do, that means you have to do an optimization. See, the person you want to satisfy somebody else will not be satisfied. So it is more of how you are able to meet the end objective, meeting all the requirements of other systems, be it aerodynamic structures, electronics, or some subsystems and all. Suppose, for example, the aerodynamics person wants a streamlined body, whereas the propulsion person needs bigger size engine, or the seeker or warhead, they want a big area and all. So it's a trade-off and compromise, like any other design. Next. So when we see, this is the timeline of our missile development program in India. Initially 1970s, that time beginning, whatever is coming, it was reverse engineering. Copy, Maki to Maki type. We don't know why it is done, why part, no, why was not at all there. Then when Dr. Kalam entered in the 1980s, when the IGDMP started, there the product was developed as same time technology required for each thing also was developed. And then to reduce time, concurrent engineering concept was there. Then slowly joint ventures, and now we have collaboration. This is how we are growing. Next. So we have centers all over the country for the missile development. Next. So this is what I was saying. When we started from that reverse engineering, when the missile, whatever is there, the jump came during Dr. Kalam's period. Next. So he was the father of this missile program. So as you know, under his guidance, these 5 missile programs, Prithvi, Agni, Akash, Nag, Trishul, all these things were developed, and each one technology was developed. That your details I will not go into that. Next. And from there he became the people president, Bharat Ratna, all those things it happened. Next. So if you see his life, he was from a village in Rameshwaram. Even now if you go, it is not fully developed. Though tourism is there, you have his museum, everything and all. When you go, it's a calm place. Fishing is the area. And because nowadays it is closer to Sri Lanka, a lot of patrolling, this, that, it is a very calm area. From there, then he graduated from St. Joseph's, Trichy. Usually MIT, we say, one thing you can keep, we are also from MIT in the older thing, Madras Institute of Technology. What the thing was, they were not success at first time people. Usually we do one basic degree in engineering, then join MIT. So Dr. Kalam also BSc Physics he did in St. Joseph's, Trichy. Then that time MIT was not giving BTech or BE. It was a diploma it used to give. So he is a DMIT, diploma in MIT, diploma in Madras Institute of Technology. So those kind of people, because they are little bit matured and they have already tasted failure, they have the more urge to succeed. So whenever you have some failure, something happen, it should urge you to put more effort to succeed. Don't get bogged down and you should not surrender. That is the message. And from there, if you see, SLV3 became the mission director, project director. Then under his guidance and Dr. Chidambaram nuclear test in Vajpayee regime, it was done. And no turning back after that, President, and the way he has put his life for motivating the youngsters and others, it's all we have seen. And another thing also you can see, you might have read in the book also, he was rejected by Air Force. He was not able to, he was not selected. But he became Supreme Commander and he has entered into the submarine, he has entered into the Su-30 aircraft, so what not. So that he could do it. Next. So these are 3 case studies were there, I will not go into that. One was SLV3, another is our Prithvi, and because paucity of time I am not going. And this was our Agni launch, where all the various things, what are the problems. See, people are seeing only the rosy side of it. So there were a lot of problems when you are doing the tensions. And even when 2-3 times they called off. Actually, this Agni flight trial, first time it was done from Balasur, one area in Orissa. So that time, that area was totally underdeveloped. And when we are launching the missile, so the safety of human beings are given utmost importance. So anything, if it is happening, failure modes you see. So when you want to do this launching, we have to vacate some 10 to 15 villages around. So 2-3 times they vacated, they didn't do that. All kind of problems were there. So then,
hello.
So, but with all these things, now what the Kalam sir has done is, Dr. Kalam, one island in Wheeler Island. So all these missile launch where we have long range, he identified a place that was belonging to the government. Then he got it for DRDO with some letters persuasion, because you know government procedures are so complicated, so many ministries involved. He got that island. Now that Wheeler Island is called Kalam Island, where we do all these long range missiles firing. Next. So as I told you, this you might have read, failure or end, anything, you should not get bogged down. That is the main thing you should have, then you will succeed. Next. So BrahMos owes a lot to Dr. Kalam, because he was the person who laid down, means the seed, laid the foundation stone. And today from nothing, it has become a 3,000 crore turnover company. And we have started exporting also. So that is the thing one person has made. One person decision and one person's commitment, it has transformed the entire thing. Next. So in fact, I am proud to say that BrahMos is one company which is having lot of youngsters delivering for the country. See, suppose for one example I can say is, even Russians, they don't have an air-launched BrahMos. We are having an air version BrahMos. So that aircraft is a Sukhoi 30 MKI, Su-30 aircraft, and this missile has to be fitted. So initially when Su-30 was conceived, designed, it was not designed to carry this BrahMos missile. BrahMos air version missile is around 2.5 tons. So how to fit it, everything and all when it is there. Then that Sukhoi Design Bureau was asking huge amount of money and time. Then it was decided by Dr. Pillai, who was the first disciple of Dr. Kalam, that why this country cannot do it. So they have roped in HAL, our DRDO specialists, other specialists from ISRO, wherever it is there, and identified less than half a dozen people from BrahMos youngsters. And those people, in the record time, it has been done, it has been flown, test fired, and it is inducted into Air Force. And this was the first Deshi missile to get the clearance also. That is how youngsters have delivered. And this was a potent weapon during even these Chinese aggressions. Because of these things, we are all safe. The point I am making is, even less than some 5-6 people with the commitment, with the guidance from the top management with the freedom to do it and the resources given, they'll deliver it. Next. So these are all the major contribution. If you see, we became the member of Space Club, re-entry class. That is, what is that generally critical about that is, when you are coming back into the atmosphere at very high hypersonic speeds, Mach 12, 20 and all, the temperature you get is too high. So whereas the inside electronics should not see beyond some 70 degrees, that carbon materials and all. And we are into that IRBM and ICBM class now. And through nuclear thing, we are a nuclear weapon state. And more than that, he became a people president too. Next. And this is a technology part. Other side, he is a nature-loving person also. What you see that the deer park is it in Orissa, where that Agni missile program was there. Few things they have kept it, and now there is a herd of deer and all. And in Rashtrapati and also they used to say he was concerned about the peacock which was injured. So a lot of nature thing morning, when many people to meet Dr. Kalam, they intercept him in during his morning walk only. Next. So these are the 5 missile program in IGDMP. Next one was Prithvi, which I have given a long learning to all of us. And this was the old technologies where you have a liquid things, a lot of smoke, so you will know where it is launched, and the missile also accelerates very slow. But from these things, we have graduated and learnt a lot. Next. And this is Akash, surface to air missile, and lot of numbers we have made. And this also is now will be exported very shortly. Next. So basically this radar detects the incoming enemy target, then the missile will be prepared, and for testing we launch an unmanned aerial vehicle. This will be the target for us. So all these things were done during Dr. Kalam's period. So this Lakshya unmanned thing is launched. Then through radar you track it and launch the missile and hit it. So this is a quick reaction one. Okay, next. So similarly, Trishul missile was developed. Next. Here one thing is that for sea thing and all, no, you have to fly at a very low altitude. So that operation we call as a sea skimming. That means within sea wave height you should consider, and you have to just fly low so that enemy cannot destroy you. That is another important thing. Next. So another was a anti-tank missile Nag. Actually in the tank, all the side portions will be armored steel and all, you cannot penetrate. Whereas the top portion will be fairly weak, where people are entering and all. So this Nag missile will have the top of attack capability. So what they say generally is that even that snake, cobra, it is more powerful, dangerous when it injects more venom when it is hitting from the top, it seems. Next. So this was the initial Agni where we were doing the technology demonstration. Next. Now we have a series of Agni missiles. Next. And beyond that, taking the cue from that, a lot of things are developed underwater and area defense and surface to air missiles and helicopter launched missiles. So many we are doing. Next. And future generally, the communication is a major thing. So enemy radars will be a target. So these kind of missiles are called anti-radiation missiles. Next. And now, as I told you, from reverse engineering and making ourselves, we have collaborations and joint ventures with the foreigners also. Now, they are not treating you as a buyer alone, they are treating you as a partner. These are the few flight trails of our BrahMos. This is against a sea target. A lot of videos are there. Maybe like when you are coming to our place, we'll show you. Then so many other classes also are developed. Next. This is what our Dr. Raja Babu and all, they were involved in that anti-satellite mission. Next. Now we are going for from supersonic, we are going for the hypersonic. It needs a lot of technologies with respect to material, engine. Still lot need to be done. And missile systems involve a lot of technologies, whether it is seeker or actuators, so many things. Even details we'll see later. Even the propulsion systems. Next. And not only the missile, it involves a lot of ground systems also and a lot of infrastructure required. Next. And test ranges, simulation, so many activities will be involved. Next. And wherever you are going to do the test, now floating test ranges have come. Next. So this is what from there. Initially when we were there, we didn't have any core competence. We have built up the core competence and facilities established. Slowly self-reliance are coming. Still there are areas like sensors, electronics, MEMS, where we still need that lot of activities. Now government is taking initiative. Probably in another within 5 to 10 years, we may be fully self-reliant, you can say. Next. Okay, this is what I can say. Now we are capable of developing whatever the current and future we need. And we have the capability, and people like you definitely joining, we can achieve much more. People on Saturday, so he has put a lot of effort to bring all under one roof. And with the Kalam's vision, see in the 600, even few percentage of people, you take this Kalam's this and you take, definitely you will transform our India into the number one. There is no single iota of doubt in that. So based on whatever both the people have talked about, only one thing I thought I will just wish you all. Professor was talking about the passion. Actually, when Dr. Kalam started our IGDMP program, Integrated Guided Missile Program, 5 missiles were there. So details we will see. So each day, he has put one of his trusted lieutenant, Dr. Sivadandu Pillai, as the program director. So each missile will be reviewed each day. They used to have a pace chamber, they call. So that pace word, I thought I will just tell you. So Professor Murthy sir was talking about the passion. So all of you, that P, you should have the passion towards your aim, that is that A. And to do that, you should have commitment, that is C. But when you are doing everything and all, it is not an easy, rosy path. You have to go through very difficulties. So that E is for endure. Only when you endure, you will achieve the goal. So I wish you all of you a great day here. You will have with lot of takeaways. You have seen lot of dignitaries here. You will have a chance to interact with them. And I thank Mr. Naresh Indian and the ACE Academy for providing this platform to meet all of you. Thank you. God bless you.